Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over the solutions to the interactive limits practice test. Now, this is going to be a real quick coverage of the solutions. If you need a much more detailed explanation, feel free to view our tutorials that will be displayed in a link at the end of this video. All right, let's take a look at number one. The limit as x approaches 0 from the left of the greatest integer of 2x plus 1. We're going to evaluate this by direct substitution. Okay, so if you substitute 0 from the left into x, you're going to have the floor of 2 times 0 from the left plus 1. Now, what do you get when you double 0 from the left? Imagine 0 from the left as being can be approximated by um, a number with an infinite number of zeros. Well, let's see, 0 from the left, so negative 0.00, infinite number of zeros, 1. Okay, so if you think about your number line, and then if you have 0 right here, 0 from the left is a number that's really close to 0 from the left hand side, something like this. Okay, so what happens when you double this? If you double this, you end up with a number that's a negative number that's really close to 0 from the left also. So this is still going to be 0 from the left plus 1. All right, so imagine doubling this number. You're still going to have an infinitely small, so it's going to be negative 0.00. Imagine you have an infinite number of zeros, and then a 1. If you double that, you have 2. So it's still a number that's really close to 0 from the left. Now, if you add these two, you're going to end up with what? What do you think you're going to end up with here? If you carry out this sum, you're going to end up with 1 from the left. Now, how is that possible? Think about 1 as a whole integer, and then 0 from the left is negative 0.0000, infinite number of zeros, and then a 1. If you subtract these two numbers, you're going to have to borrow 1 over here, and you have a whole bunch of 9s, and it's going to be 0.999, an infinite number of 9s. So if you have 1 here, where is 0.99999? It's to the left of 1, so it's as though you're approaching 1 from the left. Okay, so 1 from the left is what you get when you add 0 from the left, an infinitely large negative number, to 1. Okay, so this is what you get. Now, the floor function, what the floor function does is it rounds down. Okay, it rounds down non-integers to the biggest integer that's smaller than that integer. Okay, than that non-integer. All right, so the biggest integer that's smaller than this non-integer right here, we can write it as 0.9 repeating. If you round this down, what do you get? You get 0. So the answer is option A. All right, let's take a look at the second one, number 2. We're going to evaluate this by direct substitution also. So we're looking at a floor of negative 2 from the right over 2. Notice we're going to take the opposite of this number right here, okay, plus 2. Now, 2 from the right is a number that's really close to 2 from the right. If you divide it by 2, what do you get? You get a number that's really close to 1 from the right. Okay, so you have to be really careful when carrying out arithmetic with these numbers. Now, what happens when you take the opposite of a number that's really close to 1 from the right? To help us understand what's happening here, let's look at an example. 1 from the right can be approximated by what? Think of it as 1.00, infinite number of zeros, 0, 1. If you take the opposite of that number, what do you get? You get negative 1.00, an infinite number of zeros, and then 1. What is this? This is an approximation of negative 1 from the left. So when you take the opposite of 1 from the right, this minus changes both the sign of the number and the directionality, okay? So you want to keep that in mind. So this is going to become the floor of negative 1 from the left plus 2. Okay, now what do we get when we subtract these two numbers? we're going to end up with positive 1 from the left. Okay? So if you think about this, you're taking 2, right? And then you're subtracting this number, negative 1, from the left, which is negative 1 point, an infinite number of zeros, and then 1. What happens when you subtract this? You borrow, of course, you borrow a 1 over here, and this becomes 1, and then this becomes 10, and then you have a 9. Take a 1, 10, 9, all the way till you get over here. So you're going to, if you subtract it, you're going to have 0.999, an infinite number of 9s, right? What is this? This is the approximation of 1 from the left. So that's why we have 1 from the left here. So what is the floor of 1 from the left? We're rounding down, right? So you can think about 1 from the left as 0.9 repeating. What happens when you find the floor of that number? You end up with 0. So our answer is option letter E. All right, let's take a look at question number 3. So for problem 3, this is a directional limit of a piecewise defined function. So to do this, you always want to draw a number line and assign numbers to your intervals. Okay, we have two functions, function 1 and function 2. All right, the interval or the break happens at positive 1. So 1 is less than or equal to, let's go ahead and draw that. So less than or equal to goes right here, and that's for function number 1. Okay, and then the other one is greater than, excluding 1, every number bigger than 1, and that's for interval 2. All right, so what you want to note is that this, if you're approaching 1 from this direction, that's 1. Let me change the color here. If you're approaching 1 from this direction, that's 1 from the left. And if you're approaching 1 from this direction, that's 1 from the right. Okay? In this problem, we're approaching 1 from the right. So which function are we going to be using? 1 or 2? We're going to be using function number 2. Okay? Because that's greater. Greater is to the right. So this whole limit is basically going to become the limit as x approaches 1 from the right of the function to the right of 1, which is negative x squared plus 6x minus 10. Okay? And then we can go ahead and plug in the 1. We don't need to consider the sign anymore. Just plug in 1. So you're going to have negative 1 squared plus 6 times 1 minus 10. If you simplify this, you have negative 1 plus 5 minus, actually plus 6. Let's write that again. Negative 1 plus 6 minus 10. And your final answer is negative 5, right? Because you have 5 minus 10, which is negative 5. Option letter B. Okay, number 4 is very similar to what we did earlier. Problem 3, this is another directional limit problem on a piecewise defined function. So in this case, the break happens at negative 1. Okay, so if we have two functions, function 1 and function 2. Function 1 is less than negative 1, so less than negative 1 is every number to the left of negative 1. That's function 1. And then function 2 is active on negative 1 itself and everything to the right of negative 1. Okay, function 2. All right, now if you're approaching 1 from the left, right here, if you're approaching 1 from the left, that's going to be function 1, negative 1. From the left, function 1 will be active, and if you're approaching negative 1 from the right hand side, function number 2 is going to be active. Okay, so which one are we using in this problem? Are we using interval 1 or 2? Well, we're approaching negative 1 from the left. You see that negative sign there, the directional sign? So since we're approaching negative 1 from the left, we're looking at function number 1. we're going to be on the interval to the left, okay? So this limit basically becomes a limit as x approaches -1 from the left of -2x minus 5, because that's the function that's active to the left of -1. Okay, if you work that out by direct substitution, you're going to have -2 times -1 minus 5. The directionality doesn't matter here. So you're going to have positive 2 minus 5, and your final answer is -3, option letter B.